These days, systems need lots and lots of memory. One of the solutions that's available now is something called CXL. So can you tell us a little bit about what CXL is?
Yes. So CXL is a protocol which actually runs over the existing PCIe files. So, and the big value add of CXL is it's a coherent protocol, memory, cache and memory coherent protocol between the processor and the device, right? And because it's cache and memory coherent, a processor can do a simple memory load store operation on the device memory. Unlike PCIe, where it's considered as a MMIO or memory map IO transaction. So, and which cannot be cached. So if you are reading a cache line in PCIe, you will have to do 8 64-bit reads, one after another, right? Where here, because it's cache coherent, you can just read the first word in the cache line, and then the whole cache line shows up. And that's where the latency reduces, because now the subsequent words are already in the CPU's cache. So that's where a lot of people don't get it, but that's really why CXL reduces latency. Not so much because the electrons fly any faster in CXL versus PCIe. Like I said, it runs on the same rails as PCIe. So that's the big value prop of CXL. And as we know, the processor core counts are going up like anything nowadays, right? So I call them so many hungry mouths. And the processor people, the CPU manufacturers are already doing their best to add as many DRAM channels as they can, but there's always a limit because given for any given generation, right? So how big of a package can you make? How big of a die you can make, right? So now with CXL, you have another way to augment your system memory beyond what DRAM channels allow, right? So that's one of the big use case of CXL. Although accelerators can also benefit, but a lot of people are actually using the CXL as just simply augmenting the system memory. And once you augment the system memory, now there's more ways to access memory. So now overall system memory bandwidth goes up. Okay.
Now, in terms of the construction of the system, how are they typically building it up? Are they adding PCI Express cards to this? And is there any restriction in terms of how these are connected? Do I need a special PCIe switch for CXL, or is it the standard one?
Okay. So as you know, CXL spec has been, has evolved quickly. It started at 1.1 back in September of 2019, and then now we are at, then we went to 2.0 a year later, and then they already put out a 3.0. But today, what's really prevalent or what's coming out in the marketplace, because there's always a lag between what the device manufacturers like CPU and the endpoint devices, before they can, when they come to the market. The spec has gone ahead. But so today we are at 1.1, 2.0. 1.1 is simply what I call at the node level, right? So just like you have a PCIe card, you can add a CXL card. And the beauty of CXL, the hosts have been designed such that once you put the card in, when the link training happens, the host, the CXL card can say, I'm CXL, I'm not PCIe. So then the host will switch the right IP on the host side. So in the same PCI slot, one can use a CXL. So that's a big advantage. So they didn't have to redesign their motherboards in a big way because the same slots can be used.
Excellent.
Right? So that's number one. And then what you mentioned about CXL switches, those kind of devices would be required at 2.0 when you start doing memory pooling, right? Because now you're going further. There'll be a rack, there'll be a node in the rack, you can call it just a bunch of memory, JBOM, and where it has a switch before it. Now multiple hosts in the rack can access that, and then there'll be memory on the backside of the switch. So that's the use case, but that will happen later. But there are companies putting out switches as we speak.
Okay. Now, there are obviously multiple ways to implement the memory that's going to be sitting out there, but for the most part, isn't it just a CXL controller and a lot of DRAM, standard DRAM that we already have?
That is correct, right? So CXL, yes, it is technically a DRAM, but there can also be other use cases. In fact, one of the value adds of CXL is also to do TCO, or total reduction of TCO, right? Because you can use a lower previous generation DRAM. Like there are some vendors out there who who have controllers which can support DDR4 memory, right? So DDR4 is definitely cheaper than DDR5. And so this can help offset the cost of controller in the CXL module. And if the DDR4 prices really drop, then CXL for the same capacity, a CXL based module using DDR4 would be even cheaper than an equivalent DDR5 module, right? And then tomorrow or in future, in fact, I'm from Intel, we used to have a persistent memory called Optane, which was supposed to come out with a CXL interface. But the point is, there can also be even more cheaper memory behind CXL. Because the CXL control can hide all the latencies of the memory device, right? As long as it keeps the front side, CXL side, fully saturated. So.
Okay. Well, that was actually one area that I wanted to delve into, because when you're talking about extremely large amounts of memory, loading those initially is going to be a challenge. Recovering from errors along the way could be a challenge. Is a non-volatile CXL memory a solution, something that might be available?
Some vendors are actually trying to use NAND behind the CXL controller. Now, one thing they have to watch out for, and they often use some kind of DRAM as a cache in front of the NAND, right? Now, all this works well because normally fetches, CXL mem reads or writes are happening to that DRAM cache. But if there's a miss in that cache, now you have to fetch from the NAND device. So, and CXL, unlike a PCIe, right, it cannot time out. The mem read is just like doing a read from a local DRAM, right? So, people have to watch and design some new techniques so that if there's a miss in the DRAM cache, now you have to access the page from the NAND, which can take a few microseconds, right? So they are coming with some schemes whereby the CPU will eventually come back, right? In fact, again, with the Optane, we did something similar. And, but so that's how they will manage that, I feel. But yes, there is a chance to use NAND device behind. And CXL 2.0 also supports something called a global persistent flush feature, right? So GPF for short. So that means if you have a non-volatile device, in fact, the simple NVDIMM is a good use case. One vendor out there is actually putting out a CXL-based NVDIMM, so that if power goes down or something, CPU can issue those flush commands and things can be retired so that you don't lose any data.
That sounds very interesting. Well, thank you for filling us in on what CXL is and where it's going.
Thank you.